Hello, welcome to chapter 13, and this is the third section of the subsection of the chapter, and we'll be talking about the power rule today. So as we discussed from the previous chapter, what the first principle was, we can then generalize a case where there is a formula called the power rule that we can get from there. So firstly, let's go back to our initial case that remember that the formula was lim x x plus h and then minus f of x all over h, which was our formula for getting the gradient. And notice that let's say if I were to do it for x squared and x cubed and x to the fourth power, notice that okay, let's put it in. So let's say if I have x plus h squared minus x squared all over h, which will give us x squared plus 2hx plus h squared, and minus x squared, which cancels out, and all over h, which will cancel out too. This one cancels out, which gives us 2x plus h. But since limit h approaches 0, 2x plus h will give us 2x. So since we plug in h equals 0, and for x cubed, x squared plus 2xh, we use the previous one, x squared, and put in x plus h minus x cubed all over h, which will give us x cubed plus x squared h plus 2hx squared plus 2h squared x plus h squared x plus h cubed. Okay, there we go. And all over h. Oops, sorry for my handwriting here. And if I were to cancel minus x cubed, if I cancel all these out, I will come up with I should plugging in h equals 0 for the limit of h approaching 0, I should get the value 3x squared. And let's say if I were to do it for the function y equals x to the fourth, if I go through, you can do it yourself. If I go through it, all this through, I will get the value 4x cubed. And we write this in notation form as dy over dx. This denotes the change of the function from the change of y over the change in x. So d refers to the derivative. So this whole thing is called the derivative of the function. So let's say if I were to have y equals x to the fourth, dy over dx will equal to 4x cubed, which means the gradient essentially. So the rate of change. And for f of x, we would use the notation f prime x, which is similar. X to the fourth equals to 4x cubed. It's the same thing. But this is the Newton's notation and this is the Leibniz notation. So yeah, that's essentially what it is. Basically finding the gradient at particular points. And if I were to say if I want a particular point here, I can a gradient at a particular point, I just need to plug in, let's say x equals 2, just plug in f2, then it should be 32. So that at this point the gradient will be 32. So that's pretty much it, and that's how you write in notation like this. And hopefully when we were to notice this first principles thing, the first power gives us 2x for x squared, for the value for the function x squared, and for x cubed you get 3x squared, and for the x to the fourth you get 4x cubed. What you notice here is that the power actually is brought down. As you can see, 4x cubed, the power is brought down and the power minuses 1. So what happens is that basically if y were to be in the form x to the nth, the derivative would be the power brought down, the function itself, and the power minus 1. So that's basically the power rule in this sense, and that is pretty much it. And also perhaps one thing to denote is also that if you were to take the derivative of a constant, which is not something independent of x, we call it c, that equals to 0, since the constant has no gradient. It's just a straight line. Yep. Thank you.